All right, this is the last one. The end is near. So, day 42, we'll just go over the final today. Okay, but before we start all this stuff, I just wanted to thank you guys for a good semester. I know this is not how any of us expected or wanted our semester to turn out, but like I said in my email the other night, I've been really impressed by um, you guys and how you've handled this situation, how you've stayed engaged and remained to be good students despite, you know, probably one of the most traumatic events that we will all go through in our lifetimes. So I hope that you learned from my class. I hope that you take a little bit more appreciation if you go out in on a hike or on a trip and think about, why do my surroundings look like the way they look? Hope you liked my memes. I liked the memes you guys did. And I'm and Yeah, so thank you guys. But the reason you're all here is number one for as many rock gifts as I could find, but some logistics. Okay, so just the last things that are due are the lecture quizzes from day 40 and 41 this week. There's no lab, there's no reading quizzes. Blackboard is up to date with exception to grades for lab 10 that the TAs are doing right now. And then we've had some really awesome lab 10 entries, like some short stories, comics, like documentary style videos, some memes, obviously, some geological tours, and some are really funny, some are just really amazing, very creative. So if you are wanting to share what you did with the class, let us know. And if we see yours and think that the creativity of your project deserves to be shared, we will let you know. Okay, and we will make it available next week as sort of somewhere you can go on Blackboard, just if you want to procrastinate studying for exams or something. Okay, so now let's talk about our final. All right, so this final will be held next Thursday, May 7th. That's the original date that was scheduled for this class. And what I will do is I will make the test available from 9 a.m. to 9 p.m. Eastern Time. So I know that some of you may live in a different time zone. If you live on the West Coast or if you live across an ocean, right? Bear in mind this time difference. If you live somewhere, like if you live in China, for example, and your time difference is 12 hours, please let me know so that I can reschedule it so you can take it during a reasonable time of the day to take it, okay? I don't want you taking this in the middle of the night, right? And I also want to schedule it for a time where if you need to contact me with any sort of technical issues, that it can be done when I am awake and coherent enough to solve problems, okay? And if you have a Thursday final day from hell, meaning you have 2 or 3 other exams that day, let me know and we can work something out, okay? This exam will be a 2-hour time limit. And so what that means is if you want to use all 2 hours, don't start after 7 p.m., right? Give yourself as much time as you can, right? I will still maintain accommodations for extra test taking time for those of you who have that. And this is open book, open note, but unlike the last exam, you will only be given 1 attempt, not 2, okay? I will still do partial credit similar to last time, so don't leave anything blank, right? So now for the format. Okay, so again, it's going to be on Blackboard, multiple choice, identify from diagrams, my typical types of test, okay? It will be cumulative and about 60 questions long, all right? So 40 will be from day 28 to 41. That's weathering and sediment through earthquake hazards. And then the remaining 20 questions will be from the rest of the class. After I post this lecture and these slides, I will convert the information that's in this PowerPoint into a study guide in a Word doc so that you guys can fill it out on your own, okay? Then next week, we have office hours, right? So we'll do it on Teams like we have been. Use the main geology team, not the one for your TA. That's where we'll hold meetings, right? So you can attend any meeting with any TA. It doesn't have to be yours. And on Monday, Emily will do it from 10 in the morning till noon, and then I'll be there noon to 1. Tuesday, Hannah will be there 10 to noon, and then Wednesday, Kristen will be there 10 to noon, and I will be around noon to 1. As always, you can message me on Teams or email me with a question if those times don't work, and I will answer your question and we can video chat. Okay, I'm happy to do that next week. Okay, so let's go over what could be on the exam. All right, so our main topics from day 28 to 41, all right, our most recent block of time since the last exam are sediments and weathering, sedimentary rocks and basins, the water cycle, drainage basins and rivers and flooding, metamorphism and metamorphic rocks, and earthquakes and their hazards, okay? And then from the rest of the class, right, the main topics that we covered were the climate system, glaciers and permafrost, paleoclimate, geologic time, plate tectonics, the rock cycle, minerals and rocks, magma and igneous rocks, as well as volcanoes. Okay, so that's just the broad structure of what we covered in this whole class, right? So now I'll go into greater detail about what topics could be from the last, 14 days of class or so, since day 28. So weathering, right, you'll need to be able to define it and distinguish between physical and chemical weathering, what influences weathering reactions and physical weathering mechanisms to occur, and the different types, the effect of grain size on weathering, and then what is chemical weathering in its different types, and you'll need to understand what soil is in relation to weathering. Okay. Sedimentary rocks. For this, there's going to be quite a bit about sedimentary rocks on this exam, okay? So you'll need to know the different classes, whether it's clastic, organic, biochemical, chemical. What are the characteristics of each and how do they form? Clastic rocks will be important, right? So you need to know how to classify them. So the grain size and the resulting rock names that you get from them, right? So clay will turn into shale, sand turns into sandstone, that sort of thing. How different clastic rocks are characterized by their composition, if it's quartz or if it's feldspar or if it's mafic. The angularity, the sorting, and the cement character. And then an important thing will be understanding the relationship between the grain size, right? Like if it's a boulder versus a silt, and the amount of energy that is required in a stream to move it and transport it or deposit it. Okay. Then other sedimentary rocks, you'll need to know about biochemical rocks, like limestone, and then organic sedimentary rocks. So you'll need to understand what coal and oil shale are, right? And how these form. So what types of environments do coal rocks originate from, as well as shale. And then for chemical sedimentary rocks, understand what some common evaporites are, as well as precipitates. And I think for some of these, like especially organic sedimentary rocks and chemical sedimentary rocks, it would be good to think about how humans use these materials, right? Then sedimentary structures and environments. Okay, so you should be able to look at a picture like of this cross-bedding in Zion National Park and tell me, what type of structure you see. So this would be bedding, strata, stratification, ripples, dunes, crossbeds. as well as turbidites, right? So what is the characteristic change in grain size in a turbidite sequence? And then you need to understand different sedimentary environments. So what is moving the sediment? Is it ice, wind, or water? The expected grain size, all right? So that you need to think about the energy required to erode, to transport, and deposit sediment. And so if I gave you a environment, what type of rock would you expect to find? Right? So if I told you, all right, so you go out into the deep ocean and you core down into the seafloor sediment, what type of grain size would you find? You'd find probably clay and silt. What type of rock would eventually form from that sediment? Shale or siltstone, right? That kind of thinking. Or like I'm in a river, right, up in the high mountains where there's a really steep slopes. What type of grain size would you expect to see? Probably sands and boulders and cobbles, so maybe a conglomerate, okay? That kind of thinking. So you would want to be able to know the type of sediment you might find in each environment between glacial, desert, rivers, alluvial fans, coastal environments, and oceans. Okay? And then for oceans, I want you to think about how changes in sea level would affect the sediments that are deposited. And that's the idea of transgression, which is sea level rise, versus regression, which is sea level fall. Then for the hydrologic cycle, you need to think about the budget of different water types on Earth, like where, how much of the Earth is saltwater, how much of the Earth is freshwater, where are those reservoirs of water located, right? And then a detailed understanding of the water cycle, not just evaporation, condensation, precipitation, but thinking about all the different pathways and storage points on Earth's surface for water, from up in the atmosphere, down mountains, through the surface, through the subsurface as groundwater, and eventually out to the ocean. Right? From that, you need to think about drainage basins, the fundamental unit of rivers on landscapes, right? What defines a drainage basin or watershed? Right? So that's the some ridgeline or hillside that creates a boundary from which water flows down one side of the hill. And then I want you to think about how underlying geology would influence the type of drainage that forms, right? If it's dendritic, so looks like the branches of a tree, versus something that's radial, versus something that has a more distinct shape. Within rivers, you should have a good understanding about what discharge is, right? So what are the units? How is it measured? And how does the stream velocity vary along a profile on a stream, right? From bank to bank and water surface to the bed, right? Why is there this change in velocity along the bank edges and the bottom? Then you should know about what mechanisms for sediment transport occur in streams, right? Bed load versus suspended load, and how the bed load is the larger grain sizes that bounce and roll and are transported by the highest stream velocities at the bottom, and then the suspended load, which is smaller grain sizes and dissolved ions. You should understand why streams meander, okay? And how does the stream velocity vary along the length of a stream. Right? So this is looking at this diagram here and understanding where the thalweg is, right? The zone of maximum stream velocity, and how that relates to pools, riffles, and the deposition of point bars and the erosion of cut banks, right? On river profiles, you should know about the different zones, headwater, transfer, and deposition zone, right? And think about how different characteristics of a landscape and river system change from the headwaters down to where it meets the ocean. Right? So how does discharge, how does sediment load, how does the morphology of the river change? right? So specifically, I want to know about straight, braided, and meandering rivers and what commonly causes certain channel morphologies or shapes to occur. So this is copied from one of the lectures, but this would be something, I'm not going to give you a Google Earth assignment. We saw how that turned out. But I would give you something like give you a actual profile and ask you to identify where the headwater is or the deposition or the transfer zone, okay? Then you'll need to understand the concept of base level, right? So that is the minimum elevation to which a stream or river drains to, and what happens when you have a rise or fall in base level, right? And what could cause those changes in base level, and what evidence you can find on the landscape for past change. Then you'll need to know about hydrographs and flooding. So the main features of a hydrograph, right? The peak discharge versus the rising limb and the falling limb and base level. And as well as thinking about like changes in daily stream flow and how that could be related to a rainstorm, right, like this, versus seasonal and annual patterns in stream flow, where like on the Winooski, right, we have generally high stream flow values in the late fall and winter because of big rains, and then it gets lower in the winter when everything's frozen, and then goes back up when all the snow melts and then dries out at the end of the fall, right? So thinking and linking climate to what we see with hydrographs, okay? Metamorphism, all right? So this is the topic where you need to define what actually happens, right? What is actually happening inside of a rock or sediment as it metamorphoses, and the different processes by which metamorphism occurs. So if it is a chemical reaction, recrystallization, plastic deformation, a pressure solution, or a phase change, and the triggers that can cause metamorphism to occur, right? Changes in temperature or heat, changes in pressure, shear, which is basically the direction of how a rock is being either compressed or ripped or pulled apart, and then how hydrothermal or basically hot mineral-rich water can alter rocks, okay? For metamorphism at a broader scale, you should understand the concept of metamorphic grade in terms of pressure and temperature, right? So how does metamorphic grade advance from a relatively cold, low pressure environment to something very high pressure, high temperature? And then relate the grade back to the type of metamorphic environment, right? So look at this graph, right, and see that contact metamorphism is high temperature, low pressure, and that's because it's something coming in contact with something hot, right? So understand how each of these environments would be related to this plot here, and then think about it in a tectonic perspective, right? Why are the highest grade rocks at subduction zones, right? It's because it's really high pressure as that rock is being compressed and thrust underneath rocks, and it's not really that hot. So you get different rock types in a subduction zone versus what you might get at a like ocean spreading center where you just have hydrothermal alteration of rocks, right? Then earthquakes, the last major topic, right? So what exactly is an earthquake? What is an aseismic event versus a seismic event? What are the different types of faults? And explain the movement along them, right? Explain an actual earthquake event. So what is the difference between an epicenter and the focus of an earthquake? What is actually going on the fault during that earthquake? Then you need to know about the seismic waves that are released, right? So you need to be able to define the different types and their characteristic motion, as well as their velocity and therefore the arrival time that you would observe them on a seismograph. Further along with earthquakes, you need to understand the concept of how seismographs are used around the world to locate the epicenter of earthquakes and their magnitude, right? And you need to understand the difference between magnitude and intensity. Magnitude is a quantitative measure and intensity is a qualitative measure, and understand that the magnitude is the amount of energy released versus the intensity is the intent, like how severe the shaking and damage is. And then you need to be able to put earthquakes in a tectonic context. So what type of fault motion would you expect, and the size or magnitude of the earthquake at a divergent, a convergent, a transform, or an interplate boundary. Okay, and then you'll finish up with earthquake hazards, right? So you need to relate the hazard to the tectonic environment, right? So, why is the threat of earthquakes so high along the west coast of the United States, but generally much lower along the east coast of the United States? Right? How is that related to different plate boundaries? You need to be able to define and explain the different hazards. So whether that's shaking, right, and how that can be related to the wave motion of the seismic energy that's coming through, as well as the soil and rock type, right? Why do unconsolidated sediments and soil respond so much more severely to seismic events than solid bedrock? What is displacement and surface rupture? Why do landslides happen? Sediment liquefaction. All right, what happens specifically during a liquefaction event, and what are tsunamis? And specifically, I will harp on this, right? Water displacement of a volume of water. Know that, okay? And then you also need to understand how a tsunami wave is different from a storm wave and how it's propagated across an ocean basin. Okay, so that's 2/3 of the exam. And then the remaining topics, right? So what I would recommend that you do is look at my past exams on Blackboard, right? That would be a really good thing to study. And then the topics that I'm more than likely to address in the climate system are the difference between weather and climate, the solar energy imbalance. Do you remember my favorite graph? Best graph in the world. Okay. Global wind patterns, right? Talking about trade winds versus westerlies versus polar easterlies. Glaciers and permafrost, right? So how do glaciers form? What is mass balance? Right? So what drives glacier motion is accumulation versus ablation. And in erosional and depositional landscapes, okay. Difference between sea ice and glacier ice, right? They're different. You need to tell me why. And other topics, right? So permafrost, be able to tell me what defines the active layer for paleoclimate, what makes a good climate proxy, and specifically, what do ice cores tell us about? For geologic time, you need to know the basic principles of relative ages, right? So things like superposition, original horizontality, fossil succession, those things, and be able to recognize in a picture which the sequence of ages in a sequence of rocks, and what concept from relative dating tells us that. And that includes cross-cutting relationships and unconformities. And then major extinction events. Okay. For plate tectonics, you'll need to know about Wegener's theory of continental drift and the major topographic features of the ocean floor, right? Trenches, mid-ocean ridges, seamounts, hotspot volcanoes. And then what was the evidence that led us to understand what seafloor spreading is, or how it is occurring, and the types of plate boundaries. Then you need to know the rock cycle, okay? We have spent most of this class actually learning about the rock cycle. So you need to be able to understand the different types of rocks and the processes relating the different rock types together. Okay. Then for igneous rocks and volcanoes, you'll need to know about different igneous environments. So intrusive versus extrusive, right? So if it's a volcano versus an intrusion, the composition of the melt and the resulting igneous rock type. So be able to tell me if it's mafic, intermediate, or felsic, and be able to name different rock types, right? So granite is silica-rich intrusive rock versus a basalt, which is a mafic-rich, low silica content extrusive rock, right? What controls the magma viscosity, right, which is the temperature as well as the silica content, and what controls the eruptive style, right? So why are shield volcanoes very broad and gently sloped versus a dome or stratovolcano that is very steep and relatively small. And then finally, understanding the volcanoes in a tectonic context. Okay. I spoke through that pretty quickly, but the beauty of YouTube is that you can press pause. Okay, so I will post this now and then get a Word doc up on Blackboard. Okay, thank you.